There is more water beneath your feet right now than in every ocean on the surface of this planet combined. In this video, you will find out where it is, what it is made of, how scientists proved it exists, and why it changes everything we thought we knew about where Earth's oceans came from. We call Earth the blue planet, but that name describes a thin film on the surface. If Earth were the size of a basketball, every ocean combined would be less than a drop of moisture on its skin. The real water is below. Deep inside Earth, between 400 and 600 miles down, sits the transition zone. The pressure there is 140,000 times greater than at the surface. The temperature exceeds 2,000 degrees Fahrenheit. And inside that zone lives a mineral called Ringwoodite. Ringwoodite is a rare, deep blue crystal with a remarkable property. Its atomic structure acts like a molecular sponge. It traps water chemically, splitting water molecules and locking hydrogen into its crystal lattice as hydroxyl groups, not liquid water. A fourth state, only achievable under extreme pressure. For most of history, Ringwoodite had only been found in meteorites. In 2008, a volcano in Brazil erupted a diamond. Trapped inside was a grain of Ringwoodite, the first ever recovered from Earth's interior. When geophysicist Stephen Jacobsen at Northwestern University analyzed it, 1.5% of its weight was water. That sounds small, but the transition zone wraps around the entire planet. Jacobsen and seismologist Brandon Schmandt used over 2,000 seismometers, the USArray, to measure how earthquake waves travel through the deep Earth. Seismic waves slow down in wet rock. The signature matched exactly: water-saturated Ringwoodite beneath North America. Their conclusion, published in Science in 2014, if just 1% of transition zone Ringwoodite contains water, by weight, the total volume equals 3 times all Earth's surface oceans combined. The Pacific, the Atlantic, the Indian. 3 of them. Inside rock. But in December 2025, the story went deeper. Below the transition zone, Ringwoodite transforms under even greater pressure into Bridgmanite, the most abundant mineral on Earth, making up 60 to 70% of the lower mantle. Scientists assumed it was dry. Geochemist Wenhua Lu and Professor Jacobsen Du at the Chinese Academy of Sciences tested that assumption using a diamond anvil cell, a machine that compresses samples between opposing diamonds. They heated material to 4,100 degrees Celsius, recreating early lower mantle conditions. Their finding, published in Science, Bridgmanite absorbs dramatically more water at high temperatures. During Earth's earliest period, when the lower mantle was still molten, newly forming Bridgmanite locked away far more water than anyone had predicted. The reservoir could be 5 to 100 times larger than earlier estimates. This changes everything about where Earth's water came from. The standard answer, comets, asteroids, impacts from space, is probably incomplete. If the lower mantle stored water from the very beginning, the oceans above us may not have arrived from outside at all. They may have slowly escaped from inside. The water cycle you know, rain, rivers, evaporation, is just the surface of a far older system, a slow, billion-year circulation between rock and sea. The ocean beneath your feet is not a metaphor. It is older, deeper, and larger than the one above you.